Hey guys, welcome back. We're going to do some clustering on a cancer data set. This data set is mostly leukemia type, although it has a few others. And we're going to use it using this data set. Okay, guys, the link on my video will have a link to my GitHub where you guys can use the same data set. Okay? It'll look just like this when you're done. And then we're going to combine it and make it into a new data frame with the clusters as well. Let's dive into the code. If you guys are new to my channel, be advised, I do the full stack of data science, okay? So I do ML ops, I do AI and ML web apps, I do everything from image processing, image classification web apps, to deployments on Google Cloud, Streamlit Cloud, AWS with SageMaker, including SageMaker pipelines, getting models approved for production. I do data science like this. You name it, I got it. So check out my channel. If you're here, there's probably something else you need. I also do reinforcement learning as well. Check out some of my playlists. Also, guys, let's get started. Okay, import these libraries, read it, and then separation T, error bad lines equals false. Pass those parameters. Let's look at the head. As you can see, guys, there's 68 columns. You guys see? I thought about making this into a multi-class image classification web app. However, that's 68 columns of code. Kind of big for a Streamlit app, you know, a lot of columns. Therefore, I decided to just do a clustering video. As you can see, this is a medical data set with 68. Okay, guys, as you can see, this is everything from mutation count to very detailed, as you can see. Cancer type, age at diagnosis. To be honest, guys, if you guys want to do a multi-class classification, see some of my other videos and do cancer type as your target. You guys can. You guys just have to encode it. You guys see how most of it is leukemia, so you guys might have a class imbalance. You guys can do that as well. However, if you guys wanted to make this into a multi-class classification web app, see some of my other videos, but you'll have a lot of columns. Okay. Now we're going to drop these three irrelevant columns on an axis of 1. Okay. And in place equals false. Okay, now let's look at it again. Okay, now we're going to do the label encoder. Import all these in the as type string, lfit transform, else continue, dtype object. Okay. Fit transform. Okay, we're going to use PCA for the first part, and we're going to apply this to the K-means as well. K-means is for clustering, guys. Remember, a K-means algorithm is an unsupervised learning tool. And you use PCA as well, principal component analysis. Some people confuse the two, but principal component analysis is different. It's more like a tool. As you can see, the explained variance after you pass these parameters. MP CumSum, PCA1, explained variance ratio. Okay, there we go. And now I pass 0.8 for the end components. Fit NSS and XPCA transform NSHS. And components 2, as you can see, these are the ranges right here with the PCA 1 and 2. Okay, merge, df1 on index, as you can see, new, there we go. Now df1, the karyotype. Let's see the value counts for the karyotype. Remember, guys, that one column? Now let's look at the mean. DF mean and DF median. Guys, it's very important you get the median in data science because sometimes there's a lot of numerical imbalances. Means also, it's good to get the mean. Those are the things of each column. Okay, guys, now we have to find the best K, remember? So pass all these right here. And then we're going to do some data visualization down to find the elbow. Remember, guys, the elbow and the K-means? Now, guys, as you can see, this is somewhat debatable. However, with my eyesight, I would say this is the elbow right here, the first elbow. Some people might say number 5. However, the first one, this is more of an elbow. This is so much not. That's a little debatable. Down here, not a chance. It's too... Anyways, guys, now that I've determined it's 4 is the elbow, well, n clusters equals 4. This random state, fit, model predict NHS is the Y cluster. Remember? There's a model cluster centers. Clusters equals Y cluster, and then we're going to label the columns. As you can see, it assigns some clusters to the columns. To the rows. And then later we're going to merge this into the data frame. The newest data frame. Okay, guys, as you can see, the PLT figure. Fig size 7, 5. Scatter, reduced X, Model C labels, PLT scatter. On this index, we're going to splice. Splice here too. Marker X, red. You guys can change this to another color if you want, and you guys can change the marker to something else if you want. See some more documentation on Matplotlib for data visualization. Okay, and then PCA 1 and 2, the labels. Cancer clusters. Name this another title if you want. PLT tight layout, because it's a scatter plot. As you can see, it hit, and I'm guessing this one was trying to hit here. That's where it was a little off. It was kind of an imbalanced data set. Okay, guys. Now PD merge new. Remember? And then clusters. And then as you can see, there's the PCA from the before. So let's say hypothetically, guys, we were doing this for a medical company and we made a discovery of our own and we wanted to contribute to the data set. Okay, guys? Well, in that case, we might want to merge those 3 columns we dropped from before onto here again. You guys see? You guys can merge all that again. We could have merged those again. However, we don't need to. PCA 1, PCA 2. Now, let's see the model cluster centers. Okay. And then the variance summary. Seems at the age of diagnosis, let's look at that actually for the median and mean for that. $55 was the age, so these are 61 was the median. So guys, as you can see, this is more of an elderly person's data set. You see why it's important to get those? I just thought of a use case because I thought, hey, that could have just been the first 5 rows. No, it's not. Look. This is a more older patient study, as you can see. And then the cancer type, most of it was... You guys know you guys can you guys can decode what was encoded by the LE transform function. See my video for natural language processing where we use the LE transform function to decode predictions, like for language detection. You know, so it's more spelt out. To decode the column that you encoded, le.transform. And then you pass the correct parameter, the column. So see the LE transform function if you guys want to decode. Because leukemia is apparently, yeah. Anyways, guys, check out some of my other videos. And guys, I'm going to be making more videos. You guys don't worry. And then, guys, this is how you save it to CSV. Name it whatever you want, .csv. So it's named as a CSV file. df1. And guys, for the use case, you guys would have to merge those 3 columns we dropped from before on here so that, you know, they would know who you're referring to. However, this is just a data science project. This is not a real use case. It could be. However, you might have to add those 3 things too so they know who you're referring to as far as the patient. Remember, guys, those 3 columns we dropped? They weren't. They were going to be an inconvenience to the clustering. Yeah, these patient sample ID. So if you guys were in a real use case, you guys would have to add those, or just go back to DF and merge on DF. So you know what I mean? Or let's say DF was already encoded. You guys can figure it out. You guys are students, data science, machine learning engineers already. You guys can figure it out. Anyways, guys, stay tuned. Be sure to hit like and subscribe if you haven't already. Also, guys, I'd really appreciate if you shared my videos or if you commented on them. You know? Comment, tell me what kind of videos you guys might want to do, you know? Or just comment, shout out. Okay? Anyways, guys, I hope you like my video. Thank you. Bye.